Hey, fourth graders, welcome back to math. Now, last week when we were talking, we really focused on our types of angles that we have. We have acute angles, which are angles that are between 1 degree and 89 degrees. We have a right angle, which is exactly 90 degrees. And I could put a little sticky note inside of the corner, and it would line up perfectly. And I have an obtuse angle that is between 91 degrees and 179 degrees. Now we did have a straight angle and a reflex angle as well. But today we're going to be focusing more on acute, right, and obtuse angles. So I have one of each of those right here. I have my right angle, my acute angle, and my obtuse angle. Now if we were in class right now, I would have these drawn on the board. And I would ask you guys, think of a way that we could turn these angles into triangles. How could we do that? Think for a second. How could we turn these angles into triangles? About 8 or 9 of you guys would have your hand up right now, and I would ask you to turn and talk to your partner right now. And you guys would be talking right now, and then I would ask you guys to raise your hand again, and hopefully about almost all of you would be raising your hand right now. I'm going to start with this right angle right here. I would call on one of you, and one of you would say, well, Mr. Rush, if we just connect one of the endpoints here with the other open endpoint, like this, that makes a triangle. I just added a third side to my right angle here, and now I have 3 sides, and you need 3 sides and 3 angles to make a triangle. Well, if I did it with my right angle, I bet you I could do it with my acute angle. I'm just going to take this open side over here and connect it to my open side down here. Try to do it as straight as possible. And look at that. I have an acute triangle now. Now if I look down here at my obtuse angle, you better believe I will be able to make my obtuse angle into a triangle. Again, I'm just going to take my open side and connect it to the other open side here as straight as I can. And look at that. Not super straight, but still a triangle. It's got 3 sides and 3 angles. Now let's talk about these triangles here a second. You'll notice here I have my right angle, I have my acute angles here, and I have my obtuse angle, just like on the previous whiteboard that I had. Now we do have some new triangles here. We have a right triangle, we have an acute triangle, and we have an obtuse triangle. I'm going to tell you guys a couple different ways that you guys can identify triangles as either a right triangle, acute triangle, or obtuse triangle. Let's start over here with the right triangle. The way to identify a triangle as a right triangle is pretty easy, because if any triangle has a right angle in it, then we call it a right triangle. If you're able to fit a sticky note inside of one of the corners, then it has a right angle of 90 degrees, and it is a right triangle. Most of the time, especially in your math book, it will be identified with the little square icon there in the corner, which is very nice. So anytime you see that square icon, it is a right angle, which makes it a right triangle. Now moving over here to our acute triangle here, you'll notice all 3 of the angles on my triangle here, on my acute triangle, are acute angles. No matter which way I turn the whiteboard, all 3 angles are acute angles. They're less than 90 degrees, which makes this triangle an acute triangle. The way to find an acute triangle is if all 3 angles in the triangle have acute angles, angles less than 90 degrees. All right? So again, right triangle, 1 angle of 90 degrees. Acute triangle, 3 acute angles. And last but certainly not least, down here we have obtuse triangles. Now the way to identify a triangle as an obtuse triangle is if the triangle has 1 obtuse angle. All right? These 2 angles down here are acute, but I do have 1 angle that is greater than 90 degrees, which makes it obtuse. And therefore, I have an obtuse triangle. All right, so we have right triangle with 1 right angle, acute triangle with 3 acute angles, and we have obtuse triangle with 1 obtuse angle. Okay, so those are the first 3 that I want you guys to try to remember and practice. And again, we're going to be reviewing this for tomorrow's math lesson as well. But there are two other types of triangles, very similar, but also yet different, that I want to introduce to you guys here. First one, let's focus right up here in the corner. I have something called an equilateral triangle. Now, maybe you guys caught that at the beginning when I was saying the word equilateral. It does kind of sound like the word equal is in there, and that's kind of important. This is the way to identify an equilateral triangle is if all three sides of your triangle are equal. All right. If they are all the same measurement, same length, then we have an equilateral triangle. In the book and other places, you'll also notice that it has little lines through each of the sides to represent that the sides are equal. If it only had two lines, if it only had lines on two of the sides, then only two of the sides are equal. But here I have three lines through my sides, which represents that all three sides are equal, and makes that an equilateral triangle. Over here to an isosceles triangle, you'll notice that I only have one line through two of my sides, which means I have two equal sides. These two longer sides here are my equal sides, and this bottom line down here, the third side there, is not equal to my other two sides. We call this an isosceles triangle. Try saying that for a second. Isosceles triangle. An isosceles triangle is where we have two equal sides. Okay, remember equilateral is three equal sides. Isosceles triangle is two equal sides. So if you see a triangle with only two equal sides, a triangle with only lines through two of the sides, then that means it is an isosceles triangle. And finally down here we have a triangle called a scalene triangle. Now if you remember up here I have lines through three of my sides. Over here I have lines through two of my sides, which represents either three equal sides or two equal sides. Down here I don't see any lines through any of my sides. That means I have zero equal sides. All of my side lengths here are different lengths. None of them are equal to each other. We call this a scalene triangle. Say scalene a second. Scalene triangle. A scalene triangle is simply a triangle with zero equal sides. For your homework today, I'm going to have you guys try to identify some right triangles, obtuse triangles, acute triangles, as well as equilateral, isosceles, and scalene triangles. Let me know if you guys have any questions, and as always, wash your hands.